according. Okay. So the naive Bayes algorithm is comprised of two words, naive and Bayes, which can be described as naive, which means it is called naive because it assumes that the occurrence of a certain feature, right, is independent of occurrence of other features. Okay, so this is like you can say annotation or terminology you can say, where you will get the explanation of naive and Bayes, such as if the fruit is identified on the basis of color, shape, and taste, then red, spherical, and sweet fruit is recognized as an apple, right? So this is the perfect definition where you means the that is why we use naive Bayes as a classification. Okay, hence each feature individually contributes to identify that is an apple without depending on each other. So here we have directly used the features. Like color, we have used shape, taste, like red, spherical, and sweet. This is just example, okay? So don't confuse here. This is just definition of what naive means. And Bayes is called as it is called Bayes because it depends on the principle of Bayes theorem. Okay, so as we know, every theorems are based on that name of that scientist. So let's see the formula for that. Okay, so Bayes theorem is also known as Bayes rules or Bayes law, which is used to determine the probability of a hypothesis. So what is hypothesis with prior knowledge? It depends on the conditional probability. So hypothesis is nothing but, which means, okay, sorry. So you people have worked with no, you people have worked with thesis during your college project, right? So hypothesis is nothing but the possible explanation for something but has not yet been found to be true or correct. Means it is just assumption. Okay, we are assuming that it is okay or it is true, but it is exactly don't know is it true or not. Okay, so here is the formula for probability. Like probability of A is to B equals to probability of B is to A into probability of A and this complete term divided by probability of B. Okay, where you can say this probability of A is to B is the posterior probability. Probability of hypothesis A on the observed event B. You will get to know all this term when I'll explain it using the example. Okay. Then the probability of B to A is likelihood probability. That means a probability of the evidence given that the probability of hypothesis is true. So yes, means it will tell you your hypothesis means whatever you are assuming is true. Okay. And the probability of A is a like hypothesis before observing the evidence, as I said. And this is the probability of evidence. Okay. So this is just Bayes theorem. You already have learned it so many times. Okay. During your college or school, I think. And during your data science course as well. Okay. So there are types of naive Bayes algorithms as well. But before that, I would like to take the example for the naive Bayes theorems. Okay. So for let's take the example to predict whether a person will purchase a product on a specific combination of day, discount, and free delivery using the new Bayes classification. So let me write the statement here first so that you people can get it. Okay, so this is the main statement. We have to predict whether that person will buy the product. Combination of day discount and free delivery means, for example, if it is, for example, this is your day, this is your discount, this is your free delivery. Okay, the day column, it's like weekdays. Okay, and on weekdays, discount is yes, it is discount, and free delivery is also yes, there is a free delivery. The second is a weekend. So discount is no, free delivery is also no. So for example, this is data. Okay, you have to check that, means you have to find a probability whether this person will buy or not buy. Okay, so let's check. So now let's try to find the.
Hey, Samantha.
Okay, so let me mute first. Okay, so let's find the conditional probability. Okay, which is probability of B equals to probability of weekday. Okay, so I'll mute myself until the I complete writing. Okay. So this is our conditional probability. Okay, from where we can say this is probability of B, means your big day. Okay, you can say this is big day. Or if you make it this weekdays, yes, you means if your big day is there, like Monday to Friday, and probability of A equals to if people buy, and this is probability of B to A means probability of weekday and buy means together. Means will people buy it or not on weekday? So as you can see from the table, this is your table. I hope you people are understanding this is your table. So if you observe your data, what is your data? Data is saying that on the weekdays, discount will be there and free delivery will also be there. Okay. And on weekend, discount will not be there and free delivery will also not be there. So for example, we took the example of food. So if our product is food, we can take any other example, but most of time like this is most preferable. So if we take the example of food, during the weekdays, people are busy, right? Okay. But in a weekend, they are free, right? So anyone can tell me that will people buy the product or not? And when will they buy, on weekdays or weekend?
Ma'am, they will buy in weekdays.
Okay. But the product means people are free most of time in weekend. So
Ma'am, but in weekend they used to cook now, so they can't order or like that.
yes, exactly. Yes, that is very good answer. Okay, so even we can see here as the probability of by weekend. This is your probability of A to B, means the total probability we want. This is your formula. And this divided by is for complete this, not only that probability of by. So complete divided by probability of weekday. So if you observe as the probability of by weekend, means this is more than the probability of, means people will not buy on the weekday, we can conclude that a customer will most likely buy the product on weekday, right? On observation itself, we can say, but every time data will not be as simple as this. Okay. And another thing we learn that the most important thing in new base is when we can use the data when your number of observations are less than your features. Means in any data set, if you find your features more than your data, like a complete observation or number of rows, you can directly go for naive Bayes. Okay. And the thing is, the means that question should be of classification, right? So this is the most important part. So this was the previous. Then the types of new Bayes models, right? Gaussian, multinomial, and Bernoulli. Okay. So the Gaussian model assumes that the features follow the normal distribution. I hope you people are aware of this. Like that Gaussian distribution, it is I think this also I showed in last session. Okay, this means if the predictors take continuous value instead of discrete, then the model assumes that these values are sampled from the Gaussian distribution. Okay, so all the things are very deep. Need to explain one by one. Okay. Next is multinomial. The multinomial naive Bayes classifier is used when the data is multinomial distributed. Okay, the classifier uses the frequency of words for the predictor. And the thing is, this we most of time used in the text classification. Okay, so this is the main advantage of means every classifier is designed for one specific thing. So new base is designed for this text classification. Okay, so this is mainly for new base, and I supposed to cover. No, this is not. I supposed to cover today the practical for the new base. Okay, but due to lack of time I was not, because my broadband connection was not working, and I was working on the mobile data, so I'm sorry for that. Okay, so one another example I would like to take for the new base is, this is example one. Here you will get the example of two. Okay, so everyone is familiar with dice, right? Like head, tail. This is just simple set and simple example of dice. And what will be the its probability of occurrence? Okay.
It's coin.
Oh, sorry, it is coin. Yes, I'm sorry. Yes, it is coin, not dice. I'm sorry. And thank you for correcting me. Okay. So probability of getting heads. Can anyone tell me what is the probability for getting heads here?
1/2.
Sure. Probability of getting heads is okay. And what is the probability of getting two heads? Probability of getting two heads, 1 by.
One by four.
Yes, 1/4. It's correct. Next is probability of getting at least one tail.
Three by
Yes, it is 3/4. Yes. You can observe it that the probability of getting two heads means here only you will get the two heads. So 1/4 is your total number of observations are 4, and from 4 you will get only one times. Okay, that is how we find the probability of getting, means 4 is your total count. So if I say here, if I write here your
Man,
total count or a total number of set, it is 4, and from out of 4 you have to count everything, right? So probability of getting at least one tail, if you observe in the 3 observation, there is a one tail, at least one tail. So you will get the probability like 3/4. Okay. So these two use the simple probabilities calculated directly from the sample space. This is your sample space. So this is just the example of how you can find the probability. Means this is theory, you can like you can see here theoretical part, but if you observe here, you will get the practical examples. The next is second coin being head. Second coin being head, given first coin is tail. Can anyone tell?
Can you repeat?
Second coin being head, I'm writing there, given first point is 12.
Yeah, that's one method.
Yes. And the fourth one is,
It's 2 by
this is just a basic example how you people find probability. Okay. Getting two heads. You can find the same for the dice example where you will get how many? 6 dice are there, right? Total 6 will be there. Not 6 combination will be there. Given first point, getting two heads, given first point with head. This is also 1/2. Okay. So this is how we find probability, right? So if you added this value in this formula, okay, you will get the output. Means you will get the output of conditional probability you will get, and from that you can directly means the output will be based on which is most probable value. Okay. So here naive Bayes totally works on the hypothesis, means we don't know which is correct, but we are assuming it that this may be correct. Okay, so the main motto of naive Bayes is that it is totally on hypothesis. Okay, so here exact value also we also don't know, but by using the formula, means by using this formula, we are like taking its probability. Means this side may be correct, and from that we are finding our output. Okay, so this is about the naive Bayes theorem. So its usages are, it is very simple and easy to implement, need less training data. Okay, so you can easily use it when you have less training data, as I said. Okay, so less training data is directly means that you have less number of observations. Okay, it handles both continuous and discrete data. Okay, and one of the features is highly scalable with number of predictors and data points. Okay, so that is means this is all about the naive Bayes. If you have any doubt about this, you can ask. Okay, so let me show you one thing about this. Okay, so just wait. I'll show you the practical example we did last time. Okay, so just wait. Okay, so
ma'am, you can use markdown.
yes, I can use them just to. Okay. Actually, just wait. Let me check. Actually, last time I shared the things where I have used all the classification. I think I have not saved it. Okay, so still let me check with downloads. Actually, I have explained all the classification models with their means code, means how to implement that model. So that's what. Yes, 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 got it. So last one was our new base. Yes. So this line of code I was expecting. Yes. So if you can people see, this is the just a simple line of code where you can use the Gaussian in your not Gaussian naive Bayes classification in your model, or you can work with this. So it is not like that you can directly use this. First thing is you have to take one data set, you have to split it in the train and test. Okay, so this is X train, Y train, and your X test is there also. So I'll explain it for newly people. For previous people, I already told how to use that splitting data. Okay, so just by using this line, like for from sklearn.nav base import Gaussian and Gaussian B. So this is just a line of code from where you can get your new base classifier. Okay. By using accuracy score, you can predict your accuracy as well. So I'll show you that how I did in the last session. Okay. So this was my previous data set. Okay. One random data set was there where I have splitted the data one like in the X and in the Y. So in the Y, in the X variable, I have added all the 0 to means all its first columns, first three columns, and the last column was I added in the Y because that was target column. Or you,
Ma'am,
hello, yes, yes,
your voice is breaking.
yes, due to network issue. Okay, so this is how you can split your data: X train, X test, Y train, and Y test. Okay, so train test split will give you the means you can split your data. Test size is 0.2. That means 80% of data will go to the train and 20% data will go in the test. So if we worked with this new, okay, yes, if we see the output for the new base algorithms, you can see this is your X train, Y train, and you will get your. Am I audible?